Okay, in the last part of today, we're going to talk about operations, operators, and expressions. Since we already have variables, now it's time to see what we can do with them. So we're going to see the basic operators that JavaScript has to offer. If you know them from C#, you'll be familiar with most of them. They act in the similar way, and expressions which are also should be intuitive for anybody who has some experience writing any type of code. So operator gives us an operation that can be performed on your data, on your variables. It can take one or more variables. Most of them work on 2 variables, and there's one that works with 3 variables. And once you have an operation which is operated on your data, what you get is an expression that you can evaluate and use. Like I mentioned, there are 3 types of operators in JavaScript. They work on different number of arguments, operands. So the 1 variable, the 2 or 3. Yeah, all the binary operators are left associative. That means basically means that if you have 2 variables and you have between them an operand, then the data will be evaluated and put into the left variable. So the one on the left will be the calculation is done to the left, and this one, the specific 3 arguments variable that will 3 arguments operand operator that we'll see later works first evaluating and actually performing the actions to the right. We'll see how this works. So these are the basic operators. Starting, they have precedence. So if you write expression, if you write an expression using your variables and using these operators, they have precedence. So some of them will work before the others, just like in every other language. The highest ones is these 2 parentheses. So if you enclose your expression with these brackets, it will be first calculated. And from then on, everything else will be lower priority, lower precedence. So we have this plus, plus, and minus, minus, which will be coming later. Then we have the plus, plus, minus, minus, which are coming after the variable. So I'm not going to cover each one of those right now. We'll see them in action, but just so that you know that they have precedence and they have some order. So if you put them in parentheses, you'll know that they work first. The lowest ones, we go to the bitwise operators, and then we have, once we have an expression, we have these operators which actually are what do you call them? Logical operators. Yeah. And these assignment operators, different assignments. Once you have an expression, then it gets assigned to the left side of the equation. So let's start with the arithmetic ones. The arithmetic operators, the normal ones, plus, minus, division, and multiplications. Just like you can guess what they do. Division can return, as we've seen before, either infinity or not a number, depends on what you're trying to do to break the language. We have the remainder operator that we've also seen in action that takes 2 numbers and checks if there is a remainder in the division. And we have the increment or decrement operators of plus, plus, and minus, minus that can be put either before or after your variable to increment or decrement the number. So here's an example of a few basic arithmetic operators. So here we have a number 17, and here we are dividing it by another number, 4.25. Here we are taking the 2 numbers and we are multiplying them. Here we have again 2 numbers. We're calculating the sum. Here we are calculating the sum and then incrementing the variable b. Here we're calculating the sum again, so we can see that after this calculation, first we had 9, then we had 9 again because first this was calculated, and after that b was incremented. Then we'll have here 10. Here we have the same effect, but actually we're doing the incrementation before the sum is calculated. So we are first incrementing b and then calculating the sum. And here we're putting the sum again. And here we have a few divisions, which can result in either an integer or floating point number. Pretty straightforward, right? Here we have the arithmetic operator for a remainder. So we can see that if we divide 11 by 3, we get a remainder of 2. If we divide 11 by minus 3, we still get a remainder of 2. And if we divide minus 11 by 3, we get a remainder of minus 2. Here we have division by 0, which is perfectly fine. You can divide by 0 all you want. You'll get infinity or minus infinity. And if you divide 0 by 0 or infinity by infinity, you'll get not a number. If we have 5 minutes in the end, I'll show you a nice video about this. And here we have another division by variable which is equal to 0. So quickly to show how this works. So these are the results. I'll quickly open the code even though we don't need to. So I'm not going to go over them one by one because why should I do that? And you can see that we have divisions, like I mentioned, remainders, yeah, mostly divisions, but a few other interesting examples. So let's see the results. Notice that once we have here a floating point result, in both cases when we divide by integer or by floating point, if it needs to, it casts it into a floating point number. Here we have remainders, just like we saw, the infinity when you divide by 0. This not a number, which is a result which it cannot be calculated. Notice the true is equal to 1. Because when you divide it by 2, you get half. And notice the string 1 is also equal to 1. It gets casted into a number, and then we get again half. But a string that cannot be cast into a number, then we get not a number. And here we have a variable which contains 0, so we'll get infinity when we divide. So except these interesting examples, they should keep them in mind. Logical operators, again similar to whatever you've seen with C# and any other language. When you need to do some kind of a logical decision, we'll talk about logical operations and conditionals and loops and in the next sessions, not today, but you should probably know how these things work. So we have the double OR. These are the two pipes which actually calculate two Boolean expressions, and one of them, if one of them is true, then we get true. If one of them is false, we get the false, and then we get the end. And here we got the exclusive OR. So these basically, I don't know if I should explain exactly how they work, but you can see the tables here when you have two operands, and if one of them is true or false, you can see the result here according to the operations. These are logical operations, so they don't work on the bit level, they work on the Boolean level. They check the expression, they check the other expression or number, and then combine them and sees what is the result. If in this case there has to be one of them at least should be true, in this case both of them should be true to result in 1. So you can see this in this column. And this is exclusive OR. That means that they should be in different values so that we'll get a value of true in the end. All right with this? So an example of, again, logical operations. We have one which is true, one which is false. You can see that if we do true and false, we get false. If we do true or false, we get true. And if since they're both different, we'll get here true. We have the not operator, which is exclamation mark, which will take a Boolean value and reverse it. And then we can also combine those variables with actual true and false values. And here there's something that I'm too tired to read from start to finish, but believe me that it's something. Okay, let's take a quick look here. Okay, take 10 seconds to read it. And I hope it was 10 seconds. So similar to the logical operators, we have logical bitwise operators which work at the bit level. So we take numbers, or we take basically any variable that contains data, and we can do operations at the bit level. It means that we're taking the bit representation, the bitwise representation of this number or whatever it is, and we perform bit changes. So we can take two numbers and we can do, they'll go bit by bit, and each bit, if they are, let's say if we're using an OR, if they are 0 and 0, we'll get 0. So this OR works just like the true and false that we've seen in the logical operations. The effect is similar. Notice that this exclusive OR is similar notation as well. So we have the representation of OR and AND, and we also have these shifts. So if we have bitwise, we can shift the numbers right or left, shift the bits, shift the bits right or left as many times as you need to. How do you shift bits? You use these operators. Shift means if you have a number which is binary number, you shift it left, your left, yeah, okay, 0. Yeah, the empty, the bits get off the, yeah, they fall out, and then you have zeros padding like that, yeah. Yeah, you're cutting the most. If you're moving them right, you're cutting the least significant bit. If you're moving them left, you're cutting the most significant bit. You're cutting numbers more brutally, yes. So this is what it looks like. Here's the representation of the number 3. So in binary it will be 11, and in 5 in binary will be 101. You know this. There, no, I won't tell you binary bit jokes anyway. Yeah, there are 10. No, I will not say it. I will not tell it. So here's a logical bitwise OR that takes every bit in the number and changes it. And since this results, these two contain numbers, what we'll get is a number which will be represented by the combination of these two numbers. So it will be 2, 4, and 8. No, 1, 2, and 4 is 7. Yeah, we'll see it in a second. Then we have the bitwise AND, and then we have the bitwise XOR. Then we have a bitwise that takes all the numbers at A and reverses them and does AND to B. And here's two examples of shifting bits. So if we take true, true is actually equal to 1. So the 1 bit here was actually turned on because it was represented by the number 1 in bitwise. But since we shifted it to the left, the digit was moved one space to the right. If we take true and shift it to the right, then we lose the value because 1 gets falling off to the right and we are left with 0. Cool. Let's see if I was right. So no, how many times you shift? How many spaces you shift? Let's see if I was right. Seven. Yeah. Yeah. Okay, so here are the operations, and maybe it's worth to check the code. Great. I closed it. Okay, so we have 3 and 5, just printing out the variables, and here we are doing a bitwise operation of a or, a and, a XOR. Notice that here we have a method that takes a variable and calls toString, and if we are converting it to a string and we're calling here this argument will convert the string to a number, and this here represents the number base. So we are converting the string to a number which is binary in the base 2. Okay, you understand that? You know what number bases are, right? Or, yeah. Okay, binaries are actually data which is represented in binary code, which means zeros and ones. So, for example, here we're taking the number 7. It represented in binary code as 111. But if I take this and I change here the representation to 10, then we should have a decimal representation of the number, which is actually 7. See? Because we are counting in base 10, humans, computers in binary code. So you can convert strings to binary by using toString and putting binary, which means base 2. Okay. I think, I mean, these are all kind of oddities that you can see working at bitwise level, how things change. And basically, you need to understand what numbers are underlying. So you need to know that 3 is actually 100 and 3 is 11 and 5 is 101, and you should know what's happening in the bit level if you are doing such operations. Or if you're using something like true or false, you should know what they mean, because once you start reversing or once you start manipulating them at the bit level, you should know what to expect. So so don't do it unless you know what you're doing. In relation to the fact that we see here that things are getting equivalent to numbers, they're always, of course, equivalent to binary numbers in the memory representation of things. Maybe we'll have a minute to see some more oddities of this. Comparison operators. So there are all the basic comparison operators. We have the equal, which means to check if one variable is equal to the other. But as I'll show you in a second, it can be quite tricky, because sometimes you have two things which are equivalent at the script level, but they are not really equal to each other. If you want to check if they're really equal to each other, you use the triple equality here. And on top of that, you have the not equal and the not equal. So you can use that to know if things are really equal or not equal to each other. Then you have greater than, or less than, or greater and less than, or equal. So for example, you can see here that if you do 0 and you put an empty string, they are considered equal if you use the double equality. But if you do a triple equality, this will give you false, because they are not really the same thing. But according to JavaScript, they could be equivalent. So assignment operators, we've seen them when we assign variables, just like that, when we have a variable equal to 6 or 4, if you want 4, if that's what you like. You can also assign an increment. So if you're using the plus equals, for example, here we have a variable, we will put the number, we'll take the number 3 and we'll increment our variable by 3, or divide the variable by 2 and reassign it to itself, similar to what we have at C# and other languages as well. So I think a few examples. We have the assignments and we have regular comparisons, if this is greater than that or equal to that or not. When we're talking about checking the values, you can see that some of them are equivalent to others and some are not. I'll just get back a second to JsFiddle, because I think I have a good example related to that. Just where I put it. Okay, so what I did here, how can I remove this? I forgot. So I made a table that takes all kinds of values. For example, the Boolean value true or false, the number 1, the number -1, the string containing the word true and the string containing the word false, empty objects, undefined, infinity, not a number, all kinds of things. And you can see now what I'm doing is comparing everything in each column to everything in each row. And when I'm using triple comparisons, like I'm doing now, you can see that they are only the ones that are actually equal to each other exactly will be marked. But if I do the same thing with double comparison, many things are considered to be equal in JavaScript, even though they are not really. So if you're using the double equality, you can compare different objects of different types of different values, and you'll get true in your comparison, even though they're not the same. So 1 will be equivalent to true. This is a string, so only the string containing the word true will be used. But in many cases we have such intersections. For example, here we have an empty array which is equivalent to false, or an array containing 0, which is also equivalent to false, or an array with one object which is already equivalent to true. So this is an oddity you should know about, and you should be aware of the triple versus double equivalent when you try to check values. I think I have another demo. Not this one. Yeah, so here I've created a set of buttons, and every time I click one of those buttons, it will run a comparison. And you can see again, so for example, the green ones are actually showing ones where the double comparison is equal to the triple comparison, and in all the other ones they are different. So if you compare empty string to a string with 0, they're both not equal to each other. But if you compare 0 to an empty string, then they are different. Or if you do true and the string equals to 1, containing 1, then if you do double comparison, it's okay. But if you do triple, then they're not the same. So I think this is a important thing to be aware of, because this is a oddity. Not oddity, but that's how how these comparisons behave. Other operators, like we saw earlier, you can use the plus operator to concatenate strings. And if one of them is not a string, it will be converted to a string. We also saw this happening. So for example, now we have a string output here, the number is this, and we put a number, which is 5. We concatenate them, we'll actually get a string which contains the whole text, including the number inside it. Member access operator, we'll talk about this when we talk about objects in JavaScript. Square brackets are for arrays. We'll talk about this when we talk about arrays. Parentheses to override default precedence. So if we have parentheses, like I said, it takes precedence first. So if you do a calculation or something, you want it to be first, then you use parentheses. The conditional operator, which exists also in C# in the same way, which says check the value of b. If it's true, then execute x. If it's not, execute y. So this is a whole if, else, then in one statement. The new operator for new objects, we'll talk about this when we talk about objects. The type of, we've seen that returns types of the objects. This, we'll talk about this when we talk about more JavaScript scopes and objects, but it basically takes the object of the current context depending on the scope. We don't talk about scopes yet, so a few examples of these usages. So what we can see here, okay, so yeah, the triple operator that I just mentioned is in this line. So it takes the A and B and checks if A is greater than B. If it is greater than B, it will print this. Otherwise, it will print this string. So this is a whole if, then, else result in one line. Here we have, I think, trying to be a cast, but I'm not sure how this would work. Here we can see that we have a triple assignment. So we have a number assigning to B and then assigning the result, assigning the same thing to C. This will also work in C#, but I don't recommend to do this. It's not good practice. Here we have a few, again, comparisons to types, but again, we can try to see how this works, but I'm not sure we should discuss casting and types at this phase, this stage. So let's quickly see the other operators. So again, this is a triple operator that will take out the string according to the result of this expression. And here we have, well, parentheses to take precedence. We have here the concatenation of string and number. We have here the type of that we've already seen, and the type of an array, which is basically an object. We haven't spoken about arrays, but they are objects is also a very basic basic type in JavaScript. So everything is either this or an object. Just a little more. Expressions are actually calculations. If we take a sequence of operators and variables and numbers or strings or whichever you put together, you create expressions. So everything you see here is taking expressions and calculating them and putting them into the variable. It's pretty intuitive, right? I think we're almost done. We are almost done. Yes, that's a good demo. Could have done it without all this code. So it's trying to calculate this expression, and probably the result is false. Okay, a is greater than b, or a equal to 0 and b is equal to 0, and taking this and or and putting it, do it at home. I mean, you don't have to really dive into all this, right? Before we close, I've put here the two links that we've already seen, and I want to show you this video, which is, I don't know if you've ever seen it, but if you haven't, you should have. Every JavaScript developer has to see this video at least once in their life. It's about 5 minutes, and I think it will show you some interesting facts about JavaScript and variables, and it's really worth watching. So I'll play it for you.
Go. All right, good. You guys know what WAT means? WAT. Exactly. Let's talk about Ruby. In Ruby, if you reference an undefined variable, of course it name errors, as you would expect. And if you try to assign b to a with them undefined, of course it name errors, as you would expect. And what happens if you try to assign a to a with a undefined? Nil. Correct. Nil. WAT. Let's talk about Ruby. Ruby, unlike some other dynamic languages, does not have bare words, so you cannot just type words in and have strings come out, unless you define a particular method missing that does the right thing. And then if you type bare words, suddenly Ruby supports bare words. And in fact, it will even support bare words with bangs in them. And this is not deserving of WAT. This is actually a result of how awesome Ruby is. But if you ever actually do this, then WAT. Let's talk about JavaScript. Does anyone know in JavaScript what array plus array is? Well, let me ask you this first. What should array plus array be? Empty array, I would also accept type error. That is not what array plus array is. Wrong. Wrong. Array plus array is empty string. Obviously, I think that's obvious to everyone. Now, what would array plus object be? This should obviously be type error because those are completely disparate types. Does anyone know what this is? No. Close. No. Far away. It's object. Right. Nicely done. Now, of course, because this is plus, so you can flip the operands and the same thing comes out. So if we do, what? No, that's just an object. If you do object plus array, you should get exactly the same thing, which, as you can see, you do. And finally, the only one of these that's actually true is, because you add arrays, you get empty string, that doesn't make sense. But an object plus an object is actually not a number, technically. So this one's actually right. And exactly, right? Like, what is even going on in this lab? I don't even understand what person with a brain in their head would think that any of this is a good idea. Okay. Enough making fun of languages that suck. Let's talk about JavaScript. If I say array.new 16, or just array 16, I get an array of 16 things, which it represents as 16 commas, which is obvious. And if I then join those with a string, then I get the string 16 times. This is actually the only line in this entire presentation that's reasonable. Now, if I take that string and then add a 1 to it, it interprets the 1 as, or casts the 1 to a string, and then we get wat1 a bunch of times. Fine. Does anyone know what will happen if I subtract 1 from the string? I'm assuming no one does. I'll give you a hint. Does this help? Does anyone know? Yes. Wet man. That's all I got. Thank you, guys.
So I think this video is important because it shows some of the deep, dark corners that JavaScript can get you into. And like we've seen, there are different types of comparisons, and some objects are like this, and because JavaScript is so flexible, it sometimes gets you into some places that you don't know where you're going to end up. There's some things get converted in the background. You have castings, you have some objects becoming arrays, and arrays becoming numbers, and string becoming arrays. So you have to be aware of all this. Otherwise, it looks like it's really simple and easy, and you just can put whatever you want wherever you want, but you have to be careful with that. So I think that's our time for today, right? So that's it.